Go generics at Luno. I'm reusing some slides that I've used already. So I've introduced myself. I'm back in principal at Luno. I joined in 2016, and that's when I started using Go full time. And I've gotten to work on some very cool things. So this is a good follow-on from Walter's talk. And this is the problem that we typically face in a Go program. We have two functions that ostensibly do the same thing. But because we need type safety, we have to basically rewrite the function for each type that we want to accept. So anytime that we want a function last that takes in an array and just returns the last value in the array, we have to write a new function with the type of the elements in the array. So exactly the same function, slightly different input, but does the same thing. This is quite silly. So one way you can overcome this in Go is you can use interfaces, specifically the empty interface. So here's a function last that takes in an array of any type, and it returns any type. But there's two problems with this. The first one is that if you have an array of integers to start with, the first thing you have to do is actually convert that array of integers to an array of interfaces. So you have to create an array of interface, you have to loop over the input, you have to copy the values to the interface, you have to pass that in, and what you get back is not an integer or a string, you get back another empty interface, which you have to then cast back into int. So even though this is something that you can do in Go, you probably would never do it. It's quite a pain to do. You'd rather do that. So generics, which have controversially been absent from the Go language since its inception, have finally started creeping into the language. They were first formally proposed at the beginning of 2021 by Ian Lance Taylor, and you can read the Go issue here, and there's links to the kind of proposal document. He actually spoke together with Robert Gressimer last night at GopherCon and gave a really good overview of how generics work. So if you want to hear straight from the horse's mouth, then there's a great video on YouTube with all the details. Generics currently are available in Go 1.17. You have to add this weird flag when you build to enable them, but they'll be available in 1.18 without the flag. Luno's still stuck on 1.16. We might land up skipping 1.17 at this rate altogether. So what do generics look like? So this is the flavor of generics that Go is using is called type parameterization. And I've bolded the changes to the last function, but now we're using generics as per the latest proposal. So the first thing that you'll see here is a type parameter. So V is basically taking the place of a type. And this any is something that we call a type constraint. And basically what that's saying is that V can be any type. So just pretend that V is a variable and the value of V is actually a type. And the scope of type parameters are from the beginning of the square brackets till the end of the function. So we can actually refer to V anywhere in the function, including in its formal parameters. And here, instead of passing in a list of integers or a list of strings or a list of empty interfaces, we're actually passing in a list of type V. So whatever V is, we can pass in a list of it. And the thing that we return is also type V. So this is now looking a bit more useful. So this last function can now be used for last int, for a list of integers, for a list of strings, or a list of empty interfaces for that matter, though that's not really recommended. And we don't have to rewrite the function. When we want to actually call last, this is the syntax that we'd use. So we'd put the type, just like we're passing in an argument, we'd put the type that V is going to become into square brackets, and then we'd just pass in the type that we're working with. and last will do what you expect. An important concept in Go generics is instantiation. So when we create this function last with type int, the Go compiler actually instantiates a version of the function with that type. Just kind of FYI, the name of the symbol, it's a hash, and then the name of the function, and then it's actually got the type in the name. So you can just pretend that there's a function called last int, and it is a version of this function where v is an int, or a string, or anything else you want. So that's looking better. We can parameterize functions like we did there, but we can also add type parameters to types themselves. So here is a type called cache. It's a struct, and we've parameterized it with a type, and we can actually create a property of type v where v is anything, any type. And we can also create methods on this type. So cache with a single type parameter has a method called get, which returns v, and this is a super useless cache, but it just returns the property in the cache. And we can instantiate that type here by just saying cache with int, and we give it val10, and then we can call c.get, and we get an integer back. So we can reuse this cache type for any type. We can pass in a string, an int, whatever we want. One thing that is a little bit, so one thing to point out, that in general, well, not in general, always, the constraints that we're putting here on the type v is an interface, or an interface definition. So we can, for instance, put stringer in here, which would be an interface which just has one function, string, that returns a string. Or we could put in io.writer, and that imposes a constraint on v. V has to be an io.writer. That's fine if the things that you're going to use on this type are methods, but it doesn't really work if they're numbers, because you can't define types, you can't define methods on numbers. You can subtype the numbers, you can create your own version of an int, myInt, and give it a method, but that's a little bit awkward. So there's another new syntax called a typeset, and you can create a new interface with a set of types, an explicit set of types. And if you want to learn about the details of this typeset, the video with Ian Lance Taylor and Robert Grissomer at GopherCon really explains this very nicely. To summarize, you can think of an interface generally, like an interface that has methods, has functions, as the set of all types that implement that interface. And in general, that's an infinite set. So you can have any type that implements an interface. But here we're doing the same thing. We have a set of types. It's just that it's a finite set. It's an explicit set of types that we're passing in. So this interface represents any type. It's actually the union of these types. So it's an int or an int32 or an int64 or a float64. And this is an interface, so we can use it as a constraint on a type. And now we can do things like less than or greater than or equals, because the Go compiler sees that all the types in the number interface implement this, well, don't implement, but support that operation. And the operands, which are of type V, are going to be one of these, and we can do less than with any of those types. So this is a nice way of creating an interface where it's not functions that you want, it's sets of other types that support a particular operation. So yeah, as I mentioned, the constraints that you pass in here is just an interface. You can actually inline the word interface with curly brackets and give it functions, or you can define it like this. So you can pass in a string or a writer. And just an interesting little gotcha. So here's a version of the min function. Walter also had a version of min where we've provided three types. We've taken an A of type V1 and a B of type V2, and we return v3, which is the minimum of the two numbers. Can anyone think of what the problem with this is? Unfortunately, you can't say, but maybe you can post in chat. The issue is that A can be any type of V1, and B can be any of the V2 types. And so what you could land up here in the min function is A of type int and B of float64 or string or some other type. So it's actually important when you're writing a function like min that there's only one type parameter and all the parameters are of that type if you're going to be doing comparisons like this. So that's a kind of a brief introduction to generics. And yeah, as I say, there's already a lot of material out there. There are lots of great videos. If you want to learn more about the syntax, there are a few more additions to the language spec as part of this proposal. So they're really interesting if you want to go learn about them. But this talk is a little bit more about how specifically we're going to use generics, if at all, and kind of what the rules are. So a few things that we might be able to use generics for. We've got a library called forkjoin, and forkjoin takes in a function, and you can provide it with any number of tasks for that work function to work on. And at the end, you call join, and what you get back is an array of results where each result has an error, which might be null if it succeeded, and a result struct or result type. At the moment, to make this generally useful, we have to, the work function that we pass in here has to take in an interface and return an interface. Otherwise, it's not very useful. But of course, the problem with that is that when we use the input, we have to cast it to a type, and we're just hoping that the code that's calling this is passing in the right type. And when we eventually get the results, we have to typecast it to actually to use it. And we have to assume that forkjoin is doing the right thing and returning the right type, or at least this work function is. So let's see if we can do a little bit better with generics. So what we can do is we can add type parameters to the constructor of forkjoin. And here we're passing in some concrete type, request type, and some concrete type, result type. And we're saying that this forkjoin is going to use these two types. And now our work function can take in an actual request type and return a result type. And you can see that we've lost all the typecasting. So we've gained type safety. And we don't have to, yeah, we don't have to worry about panics. If we look at the new function, here's the new function before. It takes in a work function, which takes in an interface, returns an interface. Now we're giving new two type parameters, rec and res, which can be any. It doesn't really matter. Forkjoin doesn't care what the types are. And now, because rec and res are in scope of the whole function, we can say that the work function accepts type rec and returns type res. And we're going to return a forkjoin struct with those two types. We're going to instantiate the forkjoin struct with request and result types. And what does that look like? Forkjoin, again, we're parameterizing the struct with two types. And the result struct that's returned, we're parameterizing that as well. And we're saying that the result is of type res. And I guess you can follow the rest of the functions work pretty similarly, or the rest of the methods. So a little bit of extra work in the library itself, but we've made forkjoin now generally useful, and we don't have any of the typecasting. The interesting thing, and I haven't mentioned this in my slides, is that the compiler implements something called type inference. So actually, when we call new, we don't have to provide the type parameters when we do the instantiation. The compiler can actually go and look at where let me actually go back. Sorry, that's actually not a good example, but it can go look at the actual arguments that you've provided. So here we've provided an array of integers, and it can infer from the function signature that v is an integer. And so actually, when you call last, you don't have to provide int in brackets. And so what that means is that you can implement generics in your library without the code that's calling it having to change at all. You can implement it invisibly, transparently in your library. And in fact, I think that in 1.18, there aren't going to be any changes to the Go standard library to use generics. I think they're kind of waiting to see how generics are used. But eventually, they'll be able to use generics in the standard library, and you won't have to change any code, which is great. Another example, and quite a nice concrete example of where we're just duplicating a ton of code. Reflex is a library that Luno uses to basically we create streams of events. Like, for example, when a user changes their email address, we'll create an event to say that the user's email address has changed, and we store that event in SQL. And Reflex is a tool for streaming those events and consuming those streams. It's kind of like a message bus. You can think of it as a replacement for Kafka. And we have an abstraction for that table that stores the events. And we have one version of the events table where the foreign ID, don't worry too much about what the foreign ID is, but the column in the table is a varchar. And so here we use a string when we create the events table. And then we have to have a whole nother events table type int, which does the exact same thing, except it accepts a foreign ID of type int64. And then when we insert, we have to convert the integer to a string. Really, like, you know, it's doing exactly the same thing, except that it's an int instead of a string. So how can we change that? We can add a type parameter to the events table struct of type foreign ID. And foreign ID might be a type set, like I showed you earlier, where we had int union with int32. Maybe we can create a type set foreign ID, which is an int64 or a string. And then basically that's what we add the type parameter to the method receiver, and everything else should work because SQL should be quite happy accepting an int or a string when it inserts. And you can see here foreign ID is now type T, basically depending on what the events table was instantiated with. And we can get rid of that other type altogether, the int one. So yeah, I must be honest, when I first started working on this talk, I went and I searched hard for examples of where generics would be useful. And I actually couldn't find that many beyond the obvious ones, like obviously functions like min and Walter, like a function to return the keys in a map. There clearly generics are very useful. And maybe we'll have one package somewhere with those functions. But actually in general, we get pretty far with interfaces. So the question is, like, we have this new tool in the language, generics. How are we going to use them? Do we just go ahead and add type parameters to everything? What are the rules around it? So Robert Griesemer's talk about generics, I think in 2020, might have even been earlier, emphasized that generics are a new thing that are coming and that you shouldn't use them just because you can. And he specifically cited the examples of using concurrency. Concurrency is such a great language feature. And I think a lot of early adopters of Go just went and used channels everywhere because they're so cool. You can synchronize code without locks. And so you just use channels everywhere. And then what you find is the code becomes very difficult to reason about, it becomes very complicated, and you get all these sort of race conditions. So, you know, you might want to pare back your usage of concurrency. And I think a similar thing with generics, that there's the risk that because they're new, everyone's just going to dive in and use them everywhere. And code is going to become unmaintainable. Code reviews now become so much more complicated because you've got an extra syntax. You've got square brackets and types, and you have to, you see a V, and you have to go back to the function signature to see what the V is. And Walter, you also spoke about monads, and I mean the complexity that you can get from type parameters is astounding. And there's some examples that I've seen that are really, really difficult to read. So I think the first thing is caution. Another thing is don't use generics preemptively. So just because you can add a type parameter to a function doesn't mean you need to. And it's perfectly reasonable to write a min function that accepts an int and returns an int if that's useful in your package. And yeah, I think what I've written there solved today's problem, not the problem you think you might have tomorrow. Yeah, I think there's no reason to add complexity to a function just because you think you might need that complexity eventually. It's premature. Optimize for readability and maintainability, something very important at Luno. We have peer reviews and the team is always growing. There's always new engineers around who perhaps aren't as used to reading our code. And it's really important that our code is as readable and maintainable as possible. And generics sometimes can make your code much more readable, sometimes can make it much more complicated. You saw, although we're getting type safety and all those good things, we're also adding a whole bunch of things to the syntax that you have to model in your mind and you have to keep track of. And the last thing is when using type parameters, be as generic as possible. So this might be counterintuitive or might be very intuitive. But if you're adding a type parameter to a function, if you think you're going to need, you're only going to call it with these 5 types, for example, you might be tempted to create an interface that only uses those 5 types, like I did earlier with foreign ID. But actually, you should try and make your generics literally as generic as possible. So if you're going to add a type parameter, start with any, start with no constraints, and then kind of whittle it down. And if you need to add constraints, further constraints, add them, but don't do that first. So don't preempt it. If you're going to add the complexity of type parameters, yeah, use the most generic type that you can, the most generic type constraint. That's it. Thanks, everyone. Any questions about generics or about generics at Luno? I see there's some questions in. I will try and go through them. Marius, you ask, can generics be used on interface methods? Can't quite think of an example. I mean, they can. So you can create an interface foo and then parameterize it. And then one of the interface methods can use that type. There's an interesting red flag with generics that if you look at a type constraint, in general, the constraint is going to be an interface. It's always going to be an interface. But one of the red flags that has been mentioned is that you should never pass interfaces as the concrete types that you're passing in. So if you find that you're passing in an interface, you're probably doing something wrong, and you should probably use interfaces instead. So that's just an interesting thing to watch out for. But I think you can parameterize interfaces. Would Go generic support type inference? So yeah, I mentioned that. And there's actually a very complicated process that the compiler goes through. Not only does it infer the type, but it can actually infer other constraints as well. So it's possible, I'm trying to think of an example. In this example here, rec might be of type any. res might be of type array of rec. And so the type parameters can refer to each other. And in that case, the compiler can also infer constraints from other constraints. And that's really, really cool. And actually, Ian Lance Taylor spoke about that specifically last night at GopherCon. Really cool video if you want to go find out more about that. Chad, declaring the type when using the generic function seems verbose. Why is the proposal for generics included this extra verboseness? So I might have addressed that. That's basically what type inference does. In most cases, you don't actually, the calling code doesn't need to know that the function is implemented generically, because the compiler can do that type inference. I hope that answers your question. Cool. Just say no in chat if it didn't.
Yep, it did.
Okay, cool. Can I cast to a generic type? That is interesting. I am not sure about that. I haven't thought about it. But I think, again, to go back to my previous point, if you're kind of mixing interfaces and generics in your calling code, that might be a signal that you're not using generics properly, or you're using them prematurely. So yeah, I hope that's a useful answer. Got some code. Walter, can I write generic sum types? Type expression, T number, interface. Yes, so just looking at the first interface that you've got there, you can. So you can create a union of types where some of the types are interfaces, and those interfaces can be parameterized. So I think you can.
That's amazing.
Yeah.
Can you look at the next question? Because then that would glue it together.
If you would like, there's a version of the Go playground. I don't know the URL off by heart. That supports generics, and you can try and copy that code there and see if it runs.
Cool.
The only thing there that is a bit suspicious is the lowercase number. Although I suppose it can be an interface that's unexported.
Oh, sorry. No, I meant to say whatever the number thing is.
Mm-hmm. Yeah, interesting example there. And question with the new typesets, when I switch over the type, do I still have to write panic unreachable?
So usually when you do a type switch, right, you always have to default at the end to panic unreachable, because the type checker cannot know that you've covered all the types that have implemented the interface, right? But now, since you can pipe them, the compiler can know.
That's a good question. Again, yeah, Marius asked something similar about doing the typecasting. That's actually one thing I haven't played around with much. Cool. So I'm not sure.
That's fair.
Not sure.
But if those two questions are yes, then I would be really excited to do Go again.
Yeah, I've seen some really, really cool examples using generics. Yeah, so it wouldn't surprise me. I think there might be some questions in chat. Thanks, posting the link to the playground.
Ah, amazing.
Awesome.